Hello everyone. In this video, I'm going to talk about the basic time series forecasting methods. Look at my video about what time series forecasting is to know more about this. In this video, I'll be going over the naive method, the moving averages method, the weighted moving averages method, and the exponential smoothing method. I will create another video where I talk about extensions of the exponential smoothing method and some error analysis, right? And I will have another video but what to do when you have seasonality also, right? So this is, I'm quickly going to go through the methods and how to implement them in Excel. I'm going to try to make small 10-minute videos so that everything is in here, right? Take it. Let's get started. So the first method is a naive method. I can spell it correctly. It's a naive method. So in the naive method, naive forecast. Let's call this forecast. I'm going to insert a row here and call this the naive method. All right. So whenever we calculate a forecast, we'll always calculate error along with the forecast. So forecast in the naive method, you're saying that the forecast for any time period is exactly the same as the of the actual demand that you had in the previous time period. So for example, if your demand in the first time period was 67.25, then your forecast for period 2 will be 67.25. The forecast for period 1, we don't know. So I'm just going to say we don't know the forecast because we don't have that data. So because you need at least one data point to start making this forecast, there won't be any forecast for the first. No forecast, no error in forecast. Right, progressing. So in period 2, the forecast will be exactly the same as the demand of the previous time period. Now, this is a very simple forecasting method where you look at what you do today and your forecast for tomorrow will be that. So if you're doing something very small, say selling Girl Scout cookies, right? You're lugging around Girl Scout cookies. You go to a certain mall, cookies are sold. How many cookies should the Girl Scout take the next time she goes to the mall again? Well, it can depend upon how many boxes she sold the day before. So if you sold 50 boxes, you'll likely sell 50 boxes again the next day. So this is a simple method to forecast how many what your future demand is going to be based upon what happened in the past, just using the most recent data point, right? Now, always when you're making forecasts, using Excel, you can easily copy the formula over. You're saying that the forecast is the same as the previous demand, forecast is the same as the previous demand, and so on. And you will always be able to make forecasts for one time period in the future using any of these simple time series method. There is no actual demand because you don't know what the demand is in the next time period. You only know demand for the first 17 periods. You're going to find the demand for the 18th period. You're forecasting demand for the 18th period, and that's going to be 67.99. Now, for this forecast, you did not have to do any of the previous, calculate any of the previous forecasts, right? The reason we do it is because we want to do some analysis of how well the forecast is working. So we want to do some analysis of the error that we have in forecast, right? So we found the forecast. Let's find the error to see how much error there is in this forecast. So forecasting error is the difference between the actual demand minus the forecasted demand. So always actual minus forecast. Sometimes it'll be positive, sometimes it'll be negative. Again, remember that it only goes down to the 17th time period. No actual demand, so no error in forecast here either, right? So these were the for errors you had in individual time periods. But when you're comparing against methods, you want to aggregate all of these error into a single number, and that I will talk about in a different video. This is a video about the forecasting methods themselves. Right? So this was a naive method. Let's do a similar exercise with the next method that we talk about, which is the moving averages method. The moving averages method is an extension of the naive method in the sense that in the naive method, you're using the most recent data point only. What if you wanted to use more than just the most recent data point? What if you wanted to use the last 2 or the last 3 or the last 10 data points to make your forecast? And then the method is called the moving averages method. So we will say moving averages. This is the method that we're going to use. And whenever you do a moving average, you have to set something called a time window. So I'm going to represent the time window using capital T. So I'm going to say time window of 2, which means that I will use the last 2 data points to make a forecast for the future. So I will say forecast, if I can spell it correctly, and error. All right, that too. Jeez. All right, so forecast. So just like in the naive method where you needed one data point before you could start making one actual demand data point before you could start making forecasts, in the moving averages method, based upon the time window, you will need so many actual demand values before you can start making a future forecast. So you will need, won't be any forecast for the first 2 time periods. Again, not using this method. You might have forecast, you obviously need forecast when you're running a business, but you are not going to use this method to do that forecast. So using this method, you can start using this method in week number 3, where you have data for the first 2 weeks of demand. Now, just to clarify, I didn't say this in the beginning, but I talked about this in class. But this demand data here is demand of thousands of gallons of gas that is sold at a particular gas station, right? So that's the data that you have here. So to forecast the demand of how many gallons of gas you'll sell in week number 3, you will need data from weeks 1 and 2. And the forecast for week 3. So remember, when you're forecasting for week 3, you don't know the demand for week 3. That's going to happen during week 3. So when you forecast for week 3, you only have demands for weeks 1 and 2, right? So you're going to average the demand for weeks 1 and 2. So you have 2 data points, just average them out. That's why it's called a moving average, right? So you can say, you can either use the average formula, or you can just say sum the 2 numbers, divide by 2, and you're done, right? So that's your forecast for the next time period. So I can forecast that all the way down, right? So this is my forecast, and in fact I can forecast for 1 period into the future, and this forecast will be based upon the actual demand of the last 2 time periods, right? So again, just like the previous case, once you calculate forecast, we can calculate errors, right? And this is the difference between the actual demand and the forecasted demand, right? There you go. And that's the moving averages method. So this was a moving average method with 2 time periods. Now let's see what it looks like when you have more than 2 time periods. That'll be, let's do 3 time periods. So I'm just gonna copy that over there. Let's say if moving averages with 3 time periods, with a moving window of 3, essentially. That's what we're saying, right? Moving window is 3. So you will need 3 data points before you can make a forecast, and that'll be the last the 3 actual demand values, average them out, right? So you take the demand here, and the demand here, and then you divide by 3. Now I just want to keep 3 decimal places because there's thousands of gallons. I'm just gonna do that, right? So it's going to go all the way down, and you can go to 1 period in the future. So the next time period, the demand forecast, if you're using a 3 period moving average, is 65,790 gallons. If you're using the naive method, it's 67,990 gallons. If you're using the 2 period moving average, it is 64,045 gallons, right? Now, this is a naive method and the moving averages method, just a simple extension. Now, let's tweak this a little bit more. What if you want to use previous data points, but then you realize that the most recent data point is in fact the more important data point. The data point before that is less important, and the data point before that is less important than that. Then what do? Well, then you can do a moving average method where you can have different weights for each of the previous data points, right? So we'll do that next. But before that, I forgot to do the errors. So let's quickly calculate errors. It's the actual demand value minus the forecasted demand value. Oh, it's only 900 gallons right there, right? So there you go. No forecast, no errors, right? So the next method I will talk about is the weighted moving averages method. So because I'm getting really far away from the actual demand value, what I'll do is I will hide these columns just for the time being. Just going to right click, hide. The columns are still there, they're just hidden. This is the weighted moving average. Again, if I can spell this right. So when you do weighted moving average, I'm going to say time window is 2, right? It's still a moving average method, so you need a time window. Time window is 2, but then you also assign weights, right? So I'm going to say weights is 3, 1. So what does this mean? This means that the most recent data point gets a weight of 3, and the data point before that gets a weight of 1, which means that you're saying the most recent data point is 3 times as important as the data point before that in making this forecast, right? So it's just an extension of the way you do the moving average method. So instead of doing simple averages like we were doing before, we are going to do weighted average, right? So what does the weighted average forecast look like? So again, this is time window 2, so no forecast for the first 2 time periods. In the third time period, the forecast will be, so you multiply the weight. So the most recent data point gets a weight of 3. So 3 times the most recent data point plus 1 times the data point before that. We're not done yet. Divided by the sum of the weights. So it'll be divided by 3 plus 1. So I can just say divide by 4, but I'm just going to say 3 plus 1. So if you look at the formula, you understand what you're talking about, right? So that's the forecast. Again, I'm going to leave that 3 decimal places, and that's it. So that's the weighted moving average method. So there you go. So this is the weighted moving average method with a window of 2. We can say error, and no errors here. Oops. This is the actual demand minus the forecasted demand. Right? I'm going to break it down up to there. Right, so similarly, the final example we'll do in this video, it's already longer than 10 minutes, but let me quickly get through this. We'll do a weighted moving average with a time window of 3, and we will use weights. Let's say we'll use weights 4, 2, and 1. Always remember that the highest weight always goes to the most recent data point, next highest weight to the data point before that, and so on, right? So you're saying that the most recent data point is 4 times as important as the least important data point, and the data point next is 2. So it's like sliding scale of 2 importance, right? So let's do a forecast and also do error. So again, this is a 3-period moving average. So it's a weighted, but still 3 periods. So we need 3 periods worth of data points. So this will be 4 times the most recent data point plus 2 times the data point before that plus 1 times the data point before that divided by, well, 7. 4 plus 2 plus 1. I'm just going to say 4 plus 2 plus 1, right? There you go. So don't forget the parentheses and everything. You know how these things work. Right? Again, so I'm going to restrict that to 3 decimals. I'm going to copy this all the way down. You can go 1 period into the future with the actual forecast, but the error, you can only go up to the data that you have. So actual demand minus the forecasted demand. Right? There you go. Move this down all the way up to there. Right? And these are the simple methods: the naive method, the moving averages method, and the weighted moving averages method. All right. So I'm going to stop this video here. In the next video, we'll look at the exponential smoothing method and an extension of the exponential smoothing method when there is trend in the data. All right. So I'll see you in the next video. Take care.